Hi, welcome to another video on sequences and series. If you don't already know, my name is Anmok Abdul-Wahab and I'm a college math instructor. In today's video, we're going to look at how to solve more problems on sequences, and in specific, we'll be looking at geometric sequences here. Now, let's look at the first problem. The first problem says, find A if the seventh term of a geometric sequence is this and common ratio is this. So A is the first term, referring as A here. So the first term. Okay. So let's see how we can solve this. Now we know that what the seventh term is given. So in this, I will be using the notation A7. And don't forget, your AN is A r raised to power n minus 1. So we'll be using AN in this particular one instead of BN. And A7 would be A r raised to power what? 7 minus 1, which is 6. Okay. And we know that what A7 is 1024. And we know that what A is what we're looking for. And we know that the common ratio is what? 4 raised to power what? 6. Okay. Can we find A here? Of course, A would just be when we divide 1024 by what? 4 raised to power 6. So when we divide both sides by what? 4 raised to power 6, we get A. Now to simplify this, 1024 is same as 2 raised to power 10, if I'm not mistaken. And then 4 raised to power 6, we can simplify 4 as what? 2 raised to power 2. Don't forget the 6. And this is same as 2 raised to power 12, right? 2 times 6 is 12. And then this gives us 2 raised to power 10 minus 12, which is 2 raised to power minus 2, which again is 1 over 2 square, and this is 1 over 4. Okay, so the first term here is what? 1 over 4. It's as easy as that. All right, let's go to the second problem. Now, the second problem says, for each geometric sequence Bn, find the missing value. So we're looking for what? S7 here, and we're looking for what? S11 here. Now, this is the common ratio. We can use it. We can use R instead of Q. So we are looking for S7. Don't forget the formula for what? Sn. Sn is basically B1 R raised to power n minus 1 over R minus 1 when R is not equal to 1. So which means S7 would be B1 R raised to power 7 minus 1 over R minus 1. Now, do we know B1? Yes, B1 is minus 3 over 2. What is R? Minus 2 raised to power 7 minus 1 all over minus 2 minus 1. And this is quite easy. So let's simplify further. All over minus 3. And we can simplify the fractions. Minus 3 over 2 divide by, so this is just minus 3 over 2 divided by what? Minus 3. As you can see, it's going to be minus 3 over 2 times 1 over 3 times 1 over minus 3 multiplied by, don't forget, minus 2 raised to power 7 minus 1. So this would give us minus 3 cancel minus 3. We'll have 1 over 2 minus 2 raised to power 7 minus 1. And you can use a calculator to evaluate this. Quite frankly, these questions are quite easy. And for the second one, we are looking for S11, which is B1 again, R raised to power 10, R raised to power 11. Remember, R raised to power n, right? So R raised to power 11 minus 1 over R minus 1. Now, what is B1? B1 is 6, right? 6 times R, in this case, which is the common ratio. Oh, we don't know the common ratio in this case. So we have to stop here, right? We don't know the common ratio in this case. So how do we then solve this problem? We know what B7 is, right? And we know B2 as well. Oh, I think I got it all wrong. This problem is not this. B1 is not 6. So let's backtrack a little bit. Okay. The information that we have is what? B2 is 6 and B7 is 192, right? Okay, now let's write the formula for B2. Always make sure you write the formula for the values that you know, okay? So B2 is what? B1 times R raised to power 1, and B7 is B1 times R raised to power 6. Remember the formula, right? For the nth term of a geometric sequence is Bn, B1 R raised to power n minus 1. Good. Now that we know this, we need to solve these two equations simultaneously to find the first term, which is B1 and R. So we need to find B1 and R. And what I told you to do from the previous video is to divide, to find the ratio of the terms that you are given, the higher term over the lower one. So B7 over B2, and that will give us B1 R raised to power 6 over B1 R, and that will be 192 over 6, okay? So what does this give us? B1 will cancel out. This will give us 6 minus 1, right? Don't forget the power of R here is 1, equal to 196 divided by 6. So what is 196 divided by 6? You don't get a perfect number. So you get, so let's just leave it as that, okay? But 2 can go. So let's, 192 over 6, rather, not 196. So 192 divided by 6, that is 32. All right, this gives us 32. Perfect. So which means R raised to power 5 is 32. And what is R raised to power 5? What is 32? 32 is the same thing as what? 2 raised to power 5. So you can solve this. Once the powers are the same, we know that what the bases should also be the same. So this means R is equal to 2. It's either you do it this way or you just continue here and say R is what? 5th root of 32 when you take it to the other side, and this will give us 2 as well. Okay, so we found our common ratio now. What about the first term? You can then substitute back into one of the equations to get the first term. We know that what 6 is equal to the first term times the common ratio, which means the first term is 6 over 2, which is 3. So the first term is 3 and the common ratio is 2. We can now use this 2 information to now get what S11 is. So we are back to this. S11, let's write the formula again, is given as this. Okay? So B1, which is 3, R, 2 raised to power 11 minus 1, all over 2 minus 1. So the final answer will be 3 all over 1, which is just 3, 2 raised to power 11 minus 1. You can use your calculator to figure out this number, and that will be the solution to that problem, right? So I think this brings us to the last part of the problem set that we have on sequences and series. In the next video, you will be looking at problems with other forms of other topics in general mathematics, which will be binomial expansion and binomial theorem, right? So I hope to see you guys in the next video.